My name is Blaze Morris. Today, I'll be talking about physical network topologies. I'll be explaining the advantages and disadvantages of 5 different types of network topologies used between the early days of networking and today, and showing how information moves through those networks. You guys want to see a sick wired network? Yeah, that's what it's all about. So, there are 5 types of network topologies I'll cover in this video. We'll talk about bus networks, ring networks, star networks, mesh networks, and hybrid networks. This is a bus. And this is a bus topology. This topology, as well as the next one, were the 2 earliest types of networks. To show you how data moves through each of these networks we're talking about today, I'll demonstrate by showing you how these 2 computers talk to each other. On a bus network, every single device is attached to one main cable with 2 terminated ends. Data flows in both directions, and all data sent along the bus runs the entire length of the cable. Here's how data is sent from the top computer to the bottom right computer. And here's how it's sent in the other direction. This animation rules, and I deserve several awards for it. However, bus networks certainly do not rule and are not deserving of any such reward. You see, bus networks can stop working very easily. A single break in the main cable can bring down the entire network, and we'll talk more about why that's bad in the next slide. Here's a ring topology. Much like a bus, this ring is all one cable. However, a ring network works quite differently from a bus network. Instead of having data that flows in both directions, ring networks move data in just one, as shown in this animation. Anyway, now I'm going to break the cable. So much like bus networks, a single break in the cable can stop everything, and I'll explain why that's horrible. You already know that a break in the cable can be caused by bad actors, accidents, or rodents chewing through them. But they were also caused by adding a new device to the network. In the early days of networking, in order to add a device to a bus network, you would do so using a wiretap. Rings, much like buses, would need to be broken in order to add a new device. Wow, old networks sure were bad. You can take down an entire network if just one device or cable breaks? That's horrible. Show me something better. Here's something better. This is a star network, also known as a hub and spoke network. In a star network, each device gets its own cable, and those cables connect directly to one central device. This central device would often be a network switch, and we'll leave it at that while we're talking about wired topologies. All communication happens through this hub, so this is what it looks like for our 2 computers to send messages to each other. Good movie. The great thing about star networks is that you no longer have to worry about one cable or attached device taking down the network. You can even add to it easily. Look at this guy. He just plugged himself in while I was talking. So as you can see, this network is a great deal better than the previous 2. However, yeah, the spokes themselves can't take down the network, but the hub? No communication takes place without the hub. I'm not about that. I need a network that can still function if something fails, or even if multiple things fail. How can we possibly accomplish this? Oh, yeah, I guess you could just connect each device directly to each other. That makes things pretty simple. If you want the 2 computers to talk, they could just talk. Nothing coming between them. And if that direct connection fails, there are 3 other ways to get them to talk to each other by only going through one other device. Yeah, that's amazing. We have a perfect network, 5 devices, all connected to each other, and it only took 10 cables. However, while it may work for a small network like this one, try adding just one more device. That's messy. When the network starts getting bigger, you might start to realize that you don't actually need every single device to be directly connected to each other. You just need some level of fault tolerance not offered by the previous topologies. So let's say you realize this when you go to add a 7th device to your network. Your goal is to bring that number of cables used back down to 10, while still having a reliable, efficient, fault-tolerant network. That's good. There's no funny downside to point out, that's just a good network. This is still considered a mesh network, but to be more specific, the network we started with was a full mesh, while this would be a partial mesh. A partial mesh network is a network that has a full mesh network segment, while not every single device has a direct connection. We have one more network to talk about, but I need you to close your eyes for a second. Alright, you can open them. No, the whiteboard didn't get bigger, don't worry about it. Okay, hybrid networks. I'm sorry if this is anticlimactic, but this final topology isn't a revolutionary new idea that's better than meshes. A hybrid network is instead a term used to describe a network that combines any of these network ideas in its topology. Here's an example. This is a hybrid network that resembles the star network from earlier, but it addresses the redundancy issue caused by the switch being down. It does this by connecting each device not only to the switch, but to its two neighboring devices. This makes it also resemble a ring topology, without the baggage of the network backbone being one continuous cable where traffic only goes one way. Adding a new device to this network only adds two new cables, no matter how big the network already is. One to connect to the ring, and one to connect to the hub. And the network wouldn't need to stop at any point during this process. I guess we can't just fawn over one example. Let's see what else we got. I guess a hybrid network could also be this. Two star networks where the hubs are connected using a bus-like backbone. You know what? Don't use this one. I hate this one. Hopefully you get the idea of hybrid networks with those examples, but before I close out this video, I'd like to leave you with a few words. In networking, there's no one-size-fits-all solution. Sometimes, networks are designed to save money. Sometimes, they are designed to help a company stay within its minimum acceptable downtime. You may be surprised by what you run into in the real world. I just hope it makes sense. By the way, this is what the slide looks like on my screen. Hey, thanks for watching!